let's use that then. All right, here's number 13. So, when I take the derivative of this with respect to y, I'm going to get x prime is equal to 3y squared over 3 plus negative 1.
Why are we deriving with respect to y if our limits of integration are given as values of y? Would we want to differentiate with respect to x?
In the other version of the problem, this is dy dx,
Yeah.
and our limits of integration are in terms of x.
Right, yes, exactly.
And this is a derivative with respect to x.
Right.
So this one is, we're taking this as a derivative with respect to y,
Oh, okay, as far as, okay, good.
right? And this is going to be negative 1/4 y. Double check that derivative I just did. Is that right? Derivative of 1 over 4y is negative 1/4 over times 1 over y squared.
Yeah.
I just want to double check that. 4 times negative y to the negative 4 times negative 1 y. Well, that's not what I had there, is it? So I'm going to take that negative 1, I'm going to take that 1/4, pull it out in front. So 1/4 negative, yeah, I'm right. The derivative of this is negative 1 over 4y squared.
Wait, 4y to the negative 1, you derive it, you bring the power down, it's negative 4y to the negative second. I'm confused.
I'll do it one more time. The derivative with respect to y of 1 over 4y is equal to 1/4 times the derivative with respect to y of y to the negative first. Do you agree with there?
That's my problem. You don't need to go any further.
So we're good now? All right. So this is my dx dy. And now the arc length is going to be the integral of 1 plus t shump. So y squared minus 1 over 4y squared dy as y goes from 1 to 3. And that's going to be a perfect square. Let's find out how. So this is the integral from 1 to 3 of 1 plus y to the 4th minus 1/2 plus 1/16 1 over 16y squared. Brian, you found an earlier mistake. Did I make another mistake there? If you're doing a square, you square the first term. That's my y to the 4th. Multiply the two together and double it. Okay, you're not seeing it? You've never seen seen that, right? Take the first term, double it. Take the first term, square it. Multiply these two and double it. The last term in the square is the square.
Wouldn't it be
But it's
16 y to the 4th?
It's what happens?
Okay, this is a fourth? Sure.
Wouldn't it be that?
Yeah.
Because y squared times y squared is
Where'd you get
y
y
to the
from? It'd be
Y
plus
Okay.
squared times 1 fourth y squared.
Okay.
Right, it's a double somewhere.
So in this case, y squared squared. And on the end,
Is 1
1/4
y.
over y squared squared. So down here I'm going to get 1/16 y to the 4th, that one, okay? Here I'm going to get the y to the 4th. Now what about this middle term? 2 times a, which is y squared,
Times d.
times b, which is negative 1 over y to the, 1 over, negative 1 over 4y squared.
Yeah,
So
you're
these
good.
y squareds cancel,
So it's negative
and
2
the
over
2 and,
4.
the 2 and the 4 leave you a 1 on the bottom, double that, and you end up getting a negative 1/4
Well, it's like 1
One
over
half.
2.
over 2. Okay.
Yeah.
So at
We're
this
good.
point, I think we got it. All right. So this becomes 1, no. This becomes y to the 4th plus 1/2 plus 1 over 16y to the 4th. Combining this positive 1 with that negative 1/2. And by a miracle, I told you these are very contrived. By a miracle, this is going to be y squared plus 1/4 over y squared. Squared.
How do you know that?
Well, is the first thing a perfect square?
Yes.
Is the last thing a perfect square?
Yes.
And if you multiply these two things together,
You get a perfect square.
no. You multiply these,
Oh, you get the middle?
when you multiply those two things together
Yeah.
and double it, the squares cancel and you end up with 1/2. Because they designed it to do that. So the square root of a square leaves us y squared plus 1 over 4y squared dy. Because I don't like that. Y squared plus 1/4 times y to the negative 2. Now let's go ahead and anti-derive. 1/3 y cubed. And then this is going to be, add 1 to that, and you get negative 1. Negative 1 times 1/4 is negative 1/4. Y to the negative 1 is evaluated from 1 to 3. What's that? And then plug it in. So 3 cubed is 27, divided by 3 is 9.
9 minus 1/12.
So this is going to be negative 1/4 times 1/3, which is going to be negative 1/12, minus 1/3 minus 1/4.
No, it's plus. Oh, yeah, so you had it both of these.
Okay, cleaning that up. What do we have? Common denominator of 12. So I got 9 over, now,
111.
I've got 9 minus 1/12 minus 4/12 plus 3/12. So I've got negative 5/12 plus 3/12 is going to be 2/12 or minus 1/6. So 72, no, 54,
8 5/6.
54/6. 53/6. Blah. Yeah, and again, contrived. They have to work very hard to get something that ends up being a perfect square. They really do. All right, that's number 13. Number 15. Oh, it's going to be another perfect square. dy, no, not dy dx. Dx dy is equal to, let's see, 1/6 times 3y squared plus 1/2 times negative 1y to the negative 2. I think I did that right.
Wait, how did you put my...
Well, when I'm looking at that one, I'm thinking it as 1 over y,
2y.
1 over 2y,
Yeah.
and I don't like that, so I'll think of it as 1/2 times 1 over y. And I don't like that, so I'll think of that as 1/2
Times y to the negative.
y to the negative 1.
Okay.
Oh, okay.
And so
Okay, I see what
1/2, bring the power down, reduce the power by 1. Ugly. So this is 1/2 y squared minus 1/2 y. I'm going to write it that way. Maybe it's going to be easier to work it that way. Just leave it with the negative exponents. What do you think? I think it's quiz time.
Noah! I know. I've been here. I know what's going on.
We're doing the integrals.
Kidding them.
Let's say it, let's say it.
No, I've not. I wasn't even asleep. I really wasn't.
Alright, so there's that big mess. Alright? So let's practice our squaring. 1 plus, square that, and I get 1/4 y to the 4th. Multiply these together, I'm going to get negative 1/4, but double it, so minus 1/2. And then square that, and it's going to give me positive 1/4 y to the negative 4. Continuing on up here, that 1 and that negative 1 is going to cancel just like it did last time. So I get 1/4 y to the 4th minus 1/2 plus 1/4
Wait, wouldn't
y.
it be plus 1/2?
Yeah, wouldn't it just be plus 1/2?
Yep. There we go. And lo and behold, this is a very contrived square again, and it's 1/2 y squared plus 1/2 y to the negative 2 squared.
Are we gonna have to guess the contrived squares? Or figure out contrived squares?
I don't really have no what's the square.
Yeah.
Well, you ask
You've got the
yourself,
plus and
is the first term a perfect square?
Yeah.
Is the last term a perfect square?
Yes.
And if I multiply these two together and double it, do I get the middle term?
Yes.
And if it is, if that middle term ends up following that rule, then it's a perfect square. And then you take the square root of that and the square root of that, square root of this to get that, the square root of this to get that.
What did you do to the 1 plus?
They
Subtract
Well-
half by it.
This positive 1 and this negative 1/2 turn into a positive 1/2.
Okay.
So the square root and the square cancel, giving us 1/2 y squared plus 1/2 y to the negative 2 dy. Anti-derive, see that becomes y cubed, 1/6 y cubed plus, add 1 to that, and you get a negative 1 y to the negative 1 is evaluated from 1 to 2. I think I did that right.
Looks good.
Alright, I think that's it. So, evaluated on our bounds, we get 8/6 plus, so this is going to be 1/2, negative 1/2, negative 1/2 times positive 1/2, a negative 1/4. So there it is, evaluated at the high end. And then evaluated at the low end, got 1/6 and minus 1/2. So, I'm gonna do a common denominator of 24?
Yeah.
Why not? Sure. So, 32 24ths.
What about 12?
We could do,
Yeah.
oh yeah,
Yeah,
12.
we can do
12 would
that's
be,
easier.
12 would be even easier.
Yeah.
All right. So, 16 twelfths minus 3 twelfths minus 2 twelfths, double negative, plus 6 twelfths. So 22 twelfths minus 5 twelfths is 17 twelfths. Holy moly.
I'm not asleep.
I know what you guys are talking about, or laughing about. I'm not asleep.
Wait, he says he's a genius. I look down at my hand that has the pen that wrote all that crap,
I'm not the
and he's the genius.
I'm
And
not
you
a
should
genius,
try
I'm
to
just saying.
No, he said
Use
12
instead of 24.
instead of 24.
Oh.
So you could,
Yeah, that put us over the top. Okay, number 19. Number 19. So, how can we find a curve that goes to a particular point in which the arc length is defined there?
Okay, we take the length.
Well,
You have to you have to anti-derive.
well, that was
You have to
squared.
anti-derive. You've got 1/4x equals
We have-
dy dx.
It used to be
We have
squared,
dy
so it's
dx
squared.
already. We have dy dx already, so all we really need to do
Why-
is
why-
anti-derive.
Wait.
1 over 2
First,
is
okay.
square root of x. If you square that, it's going to be 1 over 4x. So
Right.
if you take,
So if I take the square root of it,
yeah.
it undoes the square that's
yeah.
implied
so
there.
it's 1 over 2
I have that idea written down on my page, but nothing.
and then,
Wait, let me just rewrite this as the square root of 4 times x to the negative 1/2, or this is 1 over 2
square root of x.
times, well, that's not a negative there. That's just 1/2. So dy dx seems to be 1/2 times x to the negative 1/2 power. Right? Let me try that again. Y prime is equal to 1/2 times x to the negative 1/2 power.
Okay, so what we need to do now is integrate it.
Now that's what we could do.
Or
What we're
Not what we're
going
gonna
to do.
one.
No.
FCCPT2, fundamental theorem of calculus purposes.
Not just that, but the one particular one that I keep on saying is really, really helpful. The value of a function at b is equal to the value of the function at a plus the integral from a to b of f prime.
That's see that.
And it's so
Okay, so that would be
I mean, you just do the steps backward. That's what it square it.
f1 equals f of 1 plus 1 to 1.
No, you have to. Okay.
Wait, maybe you guys are right. Maybe I can't use it here.
Just root and then
You only have it to find it 120.
Oh, no, I can't do it. I can do it, although I should probably write it
Yes, use the
differently. I'm going to use this version.
f of x.
And this should be probably with t's. So we want the function, we want that value, that y value,
Yeah.
and f of a is f of 1 plus the integral from 1 to x of f prime. And f of 1, according to this, is 1. And then then let's replace this with 1/2 t to the negative 1/2 dt.
So don't we,
1 plus 1/2, the antiderivative of this, add 1,
we're still anti-deriving.
yeah.
Right.
So we add 1 to negative 1/2,
So you get 1/2.
the positive 1/2, the reciprocal of positive 1/2 is 2 times x to the, from 1 to x.
And why'd you put X in for B again?
Well, this is great for finding at some particular location, but they're asking us to find the general function f
Symbolic.
of x. So might as well just call it, instead of calling it b, call it a general variable x.
What do you mean the general function?
We use this formula a lot when you like to say, you know, I got some velocity function, I know my position at time 1, and I'm going to find out where I am at time 3. We use this form a lot. And I'm saying, instead of having this be a number, what happens if we just say, oh, it's just the variable x, it's some value x that we don't know. All right, these two's cancel, and we end up with 1 plus x to the 1/2 minus 1. Those cancel, leaving us x to the 1/2 or the square root of x.
I think it would be easier in this situation to just take the integral.
Yeah.
So,
integrating-
so what you would have said is, okay, let's take the integral of that, you get y is equal to
root x.
1/2, add 1, and multiply by the reciprocal there, and then don't forget the plus c. So there's your step 1. And then what we need to do is take the 1, 1 in there, find out what c is. And when you do that, you get 1 is equal to 1 to the 1/2 plus c. So then it's obvious
One
that c
equal
is got to be 0 then. Okay, yeah, you're right.
Oh,
But not always.
Everyone's right.
How did you get the -1 in your
Shayna
method?
first.
Okay, how,
So,
at the first part, I don't understand how you, where the 1 went. Because it was 1 plus 1/4x.
Here's the 1, right?
Yeah, but no, the dy dx.
Where'd the 1 go for the dy dx?
Yeah, because,
Are you talking about this one here?
yeah,
Remember this form from a to b of 1 plus dy dx squared, okay? Because I'm trying to find out what the function is why, the only thing I'm concerned about is this thing.
okay.
So I said 1 is equal to 1. Oh, this has got to equal to dy dx squared.
Okay.
And that's why dy dx had to be the square root of that thing.
Okay.
How many such curves are there?
1.
Only one.
just give reasons for answering this better.
Oh, now I see. I'm good.
Yeah, just do it.
Can't just do it?
Can't just say one. If it gives
Why is there always
reasons.
one curve?
Because,
Oh,
Wait,
so-
actually, you know what?
Right?
No, the answer is actually 2.
why?
Why?
These are two.
Because dy dx could have been -1/2 x to the -1/2. If I square that, do I not still get that?
Yeah.
Bam.
So here's another starting point we could have done. The only problem is, when we antiderive that, this point can't be on that curve. Is that right?
Yeah, that point. Well, if you picture the square root of x, it cannot. I mean, it is two curves, but that's not.
No, I stand mistaken. If I derive this, or sorry, antiderive this, we get y is equal to negative square root of x plus c. Can I plug 1, 1 into here?
No.
I can't?
Well, you can,
Yeah,
but
you
your
can.
C's gonna be negative.
Is that allowed? Can C be,
Oh, yeah, you
can
can.
C be 2?
Why not?
Why not?
So they
Answer?
should have more answers, and they're.
Well, the answer, the question isn't find the curve, it's find
Okay.
a curve. So the stuff that we did is correct, and we found a curve.
But one that goes through the point 1, 1.
No, but that's also.
So
But
it's
this
still
one,
be A.
because I found this,
Okay, you're right.
in this situation, we have the negative sign, if C is 2, it could also go through 1, 1. So there are 2 such curves that
Okay.
follow that have that quality. How about that?
We're done. Let's take the quiz.
All right?